So welcome guys to my YouTube channel. So today with this woofer here, this is a Royal Sound. It's a Royal Sound woofer. Actually, there is nothing bad with the woofer, but the owner is complaining that he doesn't like the bass part of the woofer. He says that it is not sounding well. It is not giving him a deep bass. Instead, it is loud. It is rough bass. The speaker is struggling. It is a hard bass, especially at night. Music is not playing well. So he has asked me if I can try to modify the woofer and see if it can give him a good music, especially the bass part. So why don't we test before we can proceed? Yeah. So let me try using this one. Let's use Bluetooth. So this is what we are going to do. I've set this thing to Bluetooth mode, and I'm going to connect it with this phone here. I'll play some royalty-free music. So the volume here is maximum. Then let me use this hub to monitor the sound and see. So we place it at some distance. So let me disconnect this satellite speaker, test the bass alone. So from the look of things, things are not looking quite good, because let me pause this thing. It is giving us an average of 60.1 dB, and 60.1 is quite low, because if you look at the sound meter here, I'll give you a like later. So you see, for 20 is whispering, 40 is a quiet library, 60 is a conversation, and loud music is 80. So let's say 70, 80, somewhere there is good music. This thing is giving us 60. dB. And when we try to increase the volume, you have heard what is happening, it's just noise. So let me try and see if I can make this thing sound better. So I checked if there is any problem with the leakage of air from the box. There is no leakage of air, so the problem might be this thing. So this is the speaker from inside. It doesn't look that new, by the way. So this is the positive. So let me use this sellotape to mark the positive wire. So this is the positive, this is the negative. This is 8 ohm, 50 watts. I'm not sure if this is 50 watts. Let me remove these wires. Yeah, here he is. So I've set this thing to 2K. It's giving us something close to 10 ohms. Actually, I would say that this speaker is about 8 to 10 ohms. No wonder there is a problem. So this is the inside part of the woofer. You can see this is the transformer, written 14 volts 2 amperes, but we'll check that. Then this is the IC. Let me zoom. It is a STA 540. Yeah, it's a STA 540. So use the AC. Yeah. The transformer gives us 16 volts. Well, according to me, the solution can be obtained if we replace this 8 ohm speaker with a 4 ohm speaker. Now you see a 4 ohm speaker has a less impedance as compared to this one with 8 ohms. So we find the same size, same dimension, but with a lower impedance, that is the resistance. Now look here. So if you look here, this is the IC STA 540. Now this is the data sheet from the manufacturer. It's the STA 540. So it says this is a high output power. Now you see at 16 volts is capable of delivering 15 watts into a 8 ohm speaker, but will deliver 24 watts into a 4 ohm speaker. Now you see the 4 ohm is getting more power than the 8 ohm. And if you look at this page, where is that page? Yeah, this one here. This is how the woofer is connected. So this is the left speaker. So this is the left speaker here. This is the right speaker, and this is the subwoofer. So they say at 16 volts, the 8 ohm speaker will get 16 watts, but a 4 ohm speaker will get 26 watts. So that translates to more power. In short, the 4 ohm speaker will be more powerful than an 8 ohm speaker. That's why we are considering replacing. So the 8 ohm speaker at 16 volts will produce 16 watts, whereas the 4 ohm will be more powerful and will produce 26 watts even at a lower voltage of 14.4. And that's what we are looking for. Remember, to get deep music, fine music, you need more power in form of watts. Yeah. This power can be obtained by the formula power equals to voltage times current. So we measure the maximum voltage and maximum current in each speaker, then we multiply the two. So the speaker with the higher power will be the best to be put in the box because it will be providing better sound. We begin with the 8 ohm speaker, and to get the voltage, this is how we are going to connect the voltage. This one, the red one goes to the positive and the other one goes here. Base maximum, volume maximum. I think the highest I've seen is 14.82 has been 14.82 volts. So how about the current? Then we'll have the 4 ohm speaker. We find the highest voltage and the current. So let me just measure the voltage of this other speaker before I connect to measure the current. Full base. It's really vibrating. I think the maximum I've seen is 12.88 volts. It's taking less voltage than this other one. So now let's go to the current. So this is the connection from the inside of the woofer. You connect it to the positive, then the positive goes all the way up to here, then the negative goes to the other probe of the going to the speaker here. So let's see. Volume, bass. The highest I've seen is 1.94. This is 1.94 amperes. So let's check for the 8-ohm speaker. I think the highest I've seen is 1.05 amperes. So here we can conclude that the power 14.82 times 1.05 0.82 times 1.05 is giving us 15.56 watts. Well, the other one here is 12.88 times 1.94 is giving us 24.99 watts. So we round this one to the nearest figure. This is 15.5, like 16 watts, probably 25 watts. So there is a difference of 9 watts. There is a difference of 9 watts. So it is clear that the speaker is the problem. He has used a 8-ohm speaker. So now let's put it in the enclosure and test to see the bass. can see the average is getting to 60, 60s, almost 70. So I would say this one sounds more better. And now what's remaining is for us to put this cover back. So we just have to put it back and then deliver then all will be good. Thank you for watching.